Hi all, welcome to ArohiTech in Hadoop series. So in this lecture, we'll discuss about the Hadoop concepts. Okay, so so let's get started. This is my the Hadoop is a master slave architecture. So I can have one master machine and I can have multiple of slave machines. Okay, so that is called master slave architecture. So here some terminologies will discuss. What is node? Node is nothing but individual system or machine, that is called node. So this one is a node, this one also a node, this one also a node, and this one as well. And master machine, what is master machine? Master machine is the machine or node which is going to manage something in the cluster. So here I said something in the cluster, in the sense the master machine, one master machine will be doing something, will do some work, and some other master machine also can do some work. That's why I am saying here something in the cluster. So exactly you can say, if you overhaul, the master machine is the machine who can manage the entire cluster, or who can manage the slave nodes. Okay, and what is slave node? Slave node is the node which is going to store the actual data. So data cannot be stored by the master machine. The node, in the slave node only the data can be stored, and it can do the actual tasks. Only we'll discuss about here HDFS part, like the storage part, and the processing part we'll discuss in the next slide if possible, because the processing, in the sense the task management, okay, the job management. So job management, there would be another master machine we have to introduce, and there should be another client machines also. So client machine, we can take this one is the slave machine only, so it can utilize for the processing purposes, but we have to introduce another master machine that we'll discuss later. So now the I have collected the data from different data sources. So here I have taken an example file A having 100 MB. I have collected like maybe temperature recorded data or something like that. Okay, I have taken. So now this data can be distributed across the different data nodes, or we can say it is slave machines. Okay, here master machine in Hadoop technology, we can say it is a name node. Okay, name node. So how it is, why we can say name node, we'll discuss later. And this is here also in slave machine, we can say it is a data node. Okay, it is a data node, data node. Like for everyone, the same thing here, we can say data node, data. Why we can say it is a data node, that we'll discuss further. Data node. Okay, slave machine, worker machine, data node, all are same terminologies, but it is good thing we have to talk like Hadoop terminologies. So as for that, we can set it a data node, and for master machine we can set it a name node. Okay, now the file came into the picture, and file collected by the client machine, and client machine, it can collect it, and now the file will going to be divided into number of blocks, or you can say it is chunks or slices. Okay, why it is dividing? Because it's going to be distributed across the multiple of nodes. Okay, multiple of nodes. So who is dividing this blocks, the file into blocks? That's Hadoop software. So in the client machine also, I have to install the Hadoop software, so that it will be communicate with the Hadoop cluster, and it will be divided the file into number of blocks. So after dividing, so what will happen? The client will contact to the name node. The first point of contact is the name node, saying that, hey name node, I wanted to write the data, or I wanted to store the data into your cluster, in your Hadoop cluster. So please help me. So name node get to know that, okay, the file A having 100 MB, and it is divided in two blocks. It wanted to store the data into the Hadoop cluster. So name node cannot store the data. So where it wants to store? It want to store in the, only the storage part can be taken care by the slave machine or data node. The actual task or the data can be stored in the slave machines only. So now how can the master machine knows that which data node is wanted to store, which data node the blocks will be stored at this particular point of time, and who who are doing what, I mean at this particular point in time, how slave node is free, or what what is the percentage of being utilized, how much work pressure is in the slave nodes, how can it calculate? So it will pick the node. Okay, name node will pick the node who is having at this particular point of time less pressure or less workload. It will pick that node because that node should be the suitable for storage, the storing the data. So how can it knows? By each and every slave machine, they will send the heartbeat signal to the master machine. Okay, they wanted to send the heartbeat signal to the master machine every 3 seconds. Okay, every 3 seconds. Every 3 seconds, they will send the heartbeat signal to the other machine. 3 seconds. Okay, here let me make it big. Yeah, so every this one also all will send the heartbeat signal to the name node saying that I am alive. Okay, I am alive means they can communicate with each other to the master machine saying that okay, I can accept the request, whatever the things, whatever the tasks or whatever the request you wanted to make us, I can do that. I'm get ready, I'm ready. So for that reason it can send every 3 seconds, it will send the heartbeat signal to the master machine saying that I am alive. Okay, and it will send the block report. So what is block report? Block report is nothing but it will send the block report in every 1 hour. Okay, I'll write down here a little bit. Block report. Block report in every 1 hour they will send. 60 minutes. Every 60 minutes they will send a block report to the name node. By this block report, by seeing the block report, the name node can decide which data node is at this particular point of time is free or less work pressure. So in block report what it will send the workload, how much space is being utilized, how much space is free, all those details will be sending to the name node. By that way it will calculate. Okay, it will be analyzed and it will be choose the data node maybe 1 and 2. It for this point of time, at this particular point of time it can choose slave node 1 and slave node 2 or data node 1 and data node 2. Okay, it choose. Now the file is divided into number of blocks. So block 0 b0 coming to this one because the master node will guidance given the guidance to the client machine saying that okay, you can go ahead and store the data in slave 1 and slave 2 or data node 1 and data node 2. So now the things are very clear. The client have the complete information. Okay, and it is going to store the block 0 in this machine and block 1 in this machine. So that way the data is stored across the multiple of machines and we can achieve the parallelism. So it is not happening one after the another. The block 0 is writing here and at the same time the block 1 is also written here at the same time. So I can achieve parallelism by writing the data across the different data nodes. So this we can say it is a HDFS file system. So what is HDFS file system? Name node and data node. Both we can say it is a HDFS file system. Okay. So let me have a point. Name node plus data node. That is called HDFS file system. Now data is distributed across all the nodes. Okay. So this is all about HDFS file system. So the storage problem can be solved by distributing across all the nodes or different or multiple of nodes. Here two blocks, so it can accommodate two systems. Even though one system having all the capabilities, it can accept all the data, but according to the distributed file system, the blocks are distributed across different data nodes or in the two nodes or multiple of four nodes it can be distributed. Now some certain points here it is raising. So one is suppose my file having two blocks like b0 and b1. Now suppose this system having some issue. Okay, or it went down. Okay, this system got crashed or something happened due to some issue, it is not coming online. So now point is, can I read my data? Can I get my file A? The answer is no, because I can have only one block. The partial information of the file A is there, but I cannot get the complete data, so I cannot read the file. So for that reason, to mitigate that issue, there is a concept called replication factor. Okay, there is a concept called replication factor, RF, replication, REP, replication factor 3. So by default, the replication factor will be 3, and it is also configurable. So replication factor, what it says, every block should have 3 copies. So here block B0 is there, it has only 3 copies. So here where it will store, it will not store in the same machine. So duplicate blocks cannot be stored in any machine. So B0, what will happen, it should not be stored here, because duplicate copy cannot be stored in the same machine. So B0, maybe pick this one. Okay, maybe pick this one. So now B0, okay, and it will pick some other systems even though the system is not there. So it will pick two systems even though this is down, right? We can consider this is the down. So suppose it is not down, it is well in healthy condition now. Okay, it is well in healthy condition now. So okay, so now I can have B0 here, and for same thing B1 also, it would be here B1, and we can have B1 here. Okay, now things are very clear. Now I can have the B1 B0 in this machine, B1 B0 in this machine, and B1 B0 in this machine as well. Now the condition is, maybe this system goes down. Okay, it crashed, it something happened, it is not online. So can I get my complete data? Can I get the complete data? Yes, I can get it, because B1 B0 is here, so the client can read the data from this machine and for this machine as well. So I can have two more copies healthy. Okay, suppose you can say this also, this machine also having some issue, it is not online, it is crashed or something happened. So can I get the data? Yes, I can have the data in this machine as well. And make sure always it wanted to be three copies in every moment of time or any kind of situation. So now it will be, there is I mean there is three copies should be maintained, but only due to three machines here I can have only one copy. But if there would be multiple of machines, even though two systems went down or something happened to the systems, then this block will be replicated to other machines to satisfy the condition replication factor is 3. It will be replicate the data B1 and B0 to other machines. Okay, if you can have number of machines like multi-node cluster, like if the node the cluster size is more, then data node will be more, and it can replicate to other machines as well. So always it will try to maintain three copies. So this way I can mitigate this issue. So we can say it is a high availability. Any moment of time I can get the data, even though two systems went down, two systems got crashed, still I can have my data. That is the beauty of Hadoop. And coming to the name node, suppose without name node, can I get the data? No. So name node special, what it is doing is it will keep the information that is called metadata. Okay, that is called meta. What is metadata? Metadata is nothing but it will keep the complete information, like what is the slave node, what is the data node, all the information, and what is the file name A, and what is the size of the file, how many blocks it has, what is the permission of the file, and what is the replication factor, all the information of the blocks, all the information of the slave machines, it will keep in a file that is called metadata. So metadata is nothing but data about the data or information about data. Okay, again in our next session we'll discuss all those things. So the name node having only the metadata. By looking the metadata I'm sorry, by looking the metadata, it can trace, or it can find out where my file is, where my data is by the client. When the client wanted to read the data, it is not going to read like from one to from starting from this node to another node, starting from this node to the end of the node. It will not search one by one. So what will happen? It will be send the request to the master machine saying that I want to read my file A. So name node having the information. What information? Metadata. What is the metadata? All the information. So it will go through the index and it will find out, oh, okay, I got your file A. Go to the system A and go to the system B. You can get your data, or go to the system A also. You can have your complete data. So from that information it will pick the data and it can read the file very easily. Okay, that way it can happen. So this is all about today's session. We can have a very thorough discussion one by one concepts. What is metadata, how it stores, if my name node goes down, what will happen? All those things we'll discuss one by one. The complexity will be more and more when we go further and further classes. So this is all about little bit of about the Hadoop concept, and we'll discuss in our next video. Thank you so much.